Hello, so these are going to be 5-minute videos using Screencastify, and this space that you're seeing right now is me doing code, so you can see pretty math work, and then I'll also have the document, the PDF, open as a Google Doc, and I'll type this up, so both of them will be converted to PDFs and then posted on Classroom. So 5 minutes is all I can do with the free version of Screencastify, so we'll see how many times it takes. So arithmetic series is what should be in that blank on your handout that you should have. If you don't have a handout, they should be posted online already on the Classroom. So a series is a sequence, but when you're adding all the numbers up. So if you look at page 523 at the top, it tells you something like this. So a series sub 5, because they're saying it's 5 terms. It's a summation because you're adding things together. Your index starts the first term. Your upper bound will be at 5. So I'm going when I is 1 all the way up to 5. After I do a sub 1, I switch out that I, that index, it ups it 1 time. So I go to a sub 2. And I forgot some subs in there. So now I have a sub 3 and then a sub 4, a sub 5. I have auto compile on, so it will trigger as I edit. Then you can see their numbers. They have 6 plus 10 plus 14 plus 18 plus 22 because those are the numbers in their series or their sequence, but they're adding them together to make it a series that are coming from the formula on page 522. If you add those up, you get 70. So in this case, your series is going to be 70 once you had just those 5. So yeah, all right, let's back to the handout. On the foldable, let's see, where's my picture? I hope that you can see this too. So in the foldable, I'm going to make this a smaller screen so I can see it and type it. Okay, so for the arithmetic ones, we're just working on the bottom left, the bottom row in your foldable, but the left 2 boxes in that bottom row. So for sigma notation, that header, we're going to have capital sigma. We're going to have an index starting with 1. Typically that index starts with K or I. Both of those are perfectly good numbers to have used. And we're going to go to n terms. And this will be of our first term, a sub 1, plus our common difference times our index minus 1. So we're no longer putting in n, we are now putting in k as our index. Okay, so this is the sum of the first n terms of an arithmetic sequence. So a series is just sums. A series is just a sum of sequence. All right, and so that one is in there. And then the next box next to it is the arithmetic partial sum formula. So what if we only want to add a certain number? I spelled arithmetic wrong, but it shouldn't be yelling at me for that. Due to high server load, background compilation has been temporarily disabled. Okay. Anyway, I'll say it and you can see it, hopefully. I hope I'm still recording. So S sub n, so it's your series of some n number of terms, is equal to the first term plus the last term divided by 2 times the number of terms. Connections back, so I can write this down. So it's going to be S sub, capital S sub n is going to equal 2, and I want a fraction. My numerator is going to be a sub 1 plus a sub n, and then my denominator will be 2, and all of this will be multiplied by n. I want to use parentheses for n just so I don't freak it out. Okay, and that should work. I'm going to physically recompile this. Note that a sub 1 is the first term, a sub n is the nth term, and n is the number of terms that we want. So this is for a partial sum, which is like what they did on page 523 with S sub 5. So it's not the whole sum, it's not the whole series, it's just part of it. Okay, so going back, how is a series similar and different from a sequence? A sequence has all the numbers,